Yeah. So yeah, guys. So today we are going to understand about the machine learning concept. Okay, it's one of the most interesting concept that we are having in AI domain right now. Okay, and inside that we can understand what you can say, how to create some prediction model and how to what you can say right now, how to use it that prediction model in your realistic data set. Okay, so that's what we are going to understand right now. So let me just start sharing my screen. Yeah. So I guess guys, you guys can see my screen if I'm not wrong properly. Let me just create a new tab, machine learning one. Guys, I can't see the chat whenever. Generally, I will not be able to see the chat when I save the screen into the iPad and Notepad. Okay, so like if you can speak it, that is also fine for me. There is no issues. So we are going to understand about very important topic, machine learning. And let me just recap what are the things we have did it until now. So we have started the work from the web scraping, getting the data and understanding and getting the data using API. We also understood. Then we did some sort of a basic data cleaning understanding. We did it, okay, and then we did some sort of a analysis using Tableau, okay, and now we are directly going on to the machine learning concept because until we know the machine learning concept, we can't make any kind of prediction model simply. Okay, so let's go with that right now. So what is the machine learning? Let's try to understand. Please. Anyone knows anything about machine learning, guys? Anyone heard this word before? Anyone know what is machine learning, guys? Anyone? Muskan, Gargi, anyone have heard before this word machine learning, guys? Guys, tell me. Guys, machine learning, first of all, if you try to see the real use cases of machine learning in our current world right now, so you can start with your phone that you use it right now. Inside that, you have facial recognition system, okay, where you see your phone, the face would get unlocked. You are having fingerprint scanner and all. It is not by default. There are some machine learning algorithm is also used in fingerprint. There are stressed like a self-driving car that is running on the road. That is also example of machine learning. Chat GPT is machine learning. Sometime in the businesses we need to forecast the future sales, future prices. That is also a machine learning example. Okay, so machine learning, we need to understand what is machine learning first of all. So machine learning is nothing but, guys, we are having understand, this is, we call it as a machine. Okay, this is our machine, and this machine is nothing but, guys, this machine is having algorithm. This machine is nothing but it's algorithm. And which kind of algorithms, if we try to understand, it is nothing but, guys, mathematical algorithm, right? Mathematical algorithm right now. So this machine is nothing but, you can say, it's a set of mathematical formula we are having right now. Inside that mathematical formula, what we are trying to do, we are trying to feed some data, okay, inside that mathematical algorithm, mathematical formulas, we are trying to feed the data. So now what it is happening inside this machine, our machine is getting trained with the data, and with the training data it would be now able to make some sort of a future prediction. Future prediction right now, that is a simple example of machine learning. Machines is there, machine is nothing but, guys, what I told you, it's a set of what you can say, mathematical formula, algorithm and all right now, where you are sending some sort of a data, and then our machine is getting trained on the data, and now it would be able to make some sort of a future prediction. That is the simple example of a machine learning we are having right now. Now the thing is like that, if you try to understand one thing, guys, that we are able to train our machine with the data, and it is able to make some sort of future prediction, where we use that future prediction everywhere, guys, in modern days. Some whether it is getting forecasted right now, what would be tomorrow's weather, it's a machine learning example. Stock prices will go up and down, machine learning example right now. Okay, you are trying to create some image recognition system, whether it's a cat or a dog, it's a machine learning example. Everything comes under the machine learning. Whatever you guys learn it, and whatever the prediction model you guys created, that comes under the machine learning. And this is one of the interesting topic that I can say we are having right now. Now, machine learning, guys, is actually divided into multiple parts. Machine learning, it is divided into multiple parts right now. What are the parts it has been divided? The machine learning is divided inside, guys, what you can say, supervised learning. Okay, we call it as a supervised learning. Then we are having unsupervised learning, guys. Unsupervised learning. Then we are having right now deep learning, guys. Okay, deep learning we are having. Then we are having reinforcement learning. Reinforcement learning. Main learning. Just a very simple example of everything I'm going to give it right now to you guys. Okay, so supervised learning example I can give you. First of all, just see the example only. So suppose, guys, you are doing future stock price prediction, future sale predictions. Okay, you are doing what you can say, uh, future profit and loss prediction right now, weather predictions you are doing right now. That everything comes under the supervised learning right now. These all things come under the supervised learning. Okay. Now unsupervised learning, what does the things comes in unsupervised learning? These things come, guys, right now. uh, Whether you are going to give a loan offer to these people or not. Okay, whether you are going to give how much loan to each and every employee, how whether you are going to give the credit card to this person or not right now. Okay, if you're giving credit card, what is the offer you're going to apply onto that credit card? Clear example, I will clear cut example and difference between supervised and unsupervised I will make you understand. But I wanted to little bit focus, just a little bit focus on deep learning and reinforcement learning actually. So deep learning is something you can say, guys, right now. Deep learning is nothing but where the problem is very complex. Problem is already very complex. If you understand what is the kind of problem is very complex right now. Suppose we are saying that, okay, you have to create a system that will recognize human face. Okay, so human face recognition, guys, it's a very tough task, it's a very complex task, it's not a very easy task right now. There is a huge complexity of the data we are having, we have to use complex algorithm for it. So those complex data we can solve inside the deep learning only, using neural networking concept. Okay, so deep learning is the place where we try to solve the complex problem. Facial recognition system, image recognition system, you can say sentiment analysis. Okay, whether the review is positive or negative right now. So these kind of analysis we can do in deep learning. And reinforcement learning is already, it's very interesting topic, or it's a different kind of domain in the AI, you can say right now, where we actually understand how to create the robots. Okay, how to create software or the mind of the robots actually. Okay, so the, like, what you can say right now, the self-driving car you guys see, na, Tesla self-driving car and all. So there is a very classical example of reinforcement learning has been applied. So that car is nothing but it's like acting like a robot, right? Okay, so all the robotics works that has been done into the modern era, modern days right now, it just fall under the reinforcement learning, guys. Okay, we are not going to focus on deep learning, reinforcement learning and all this thing, because obviously it's a separate topic and separate domain into it right now. We will understand from the basic, we will start from the scratch. So we will start understanding from the supervised learning, guys, right now. Okay, so let's start understanding supervised and unsupervised learning. And unsupervised. So if you try to, if I try to ask you something, guys, suppose this is the age of the person. Okay, and this is the salary of the person. Okay, Using the age, we have to predict the salary of the person. So using age is our X data. We are calling age our X data. Age we are calling as a input data. Input data. Age we are calling as a independent data. Why we are calling all this thing, I will tell you right now. So why I'm telling that using age, we have to predict the salary of a person. Salary will be what kind of a data, guys? It would be Y data we are calling. We are denoting as a Y data. We are calling it as a output data. Output data. We are calling as a dependent data, guys. We are calling as a dependent data because salary is totally depend upon the age of the person based upon our data, whatever we are having. So suppose I'm writing age is 20, 21, 22, 23. Okay, and salary of the person is like this: 50K, 60K, 70K, 80K. I'm asking you one simple question: what would be the salary of age 24, guys? What would be salary of age 24? What would be, guys? Tell me honestly, what would be the salary of age 24 people?
90K.
90K. Very good. It would be 90K right now.
90K.
So if 90K. If you try to understand this thing, guys, you are able to make some prediction. You are able to make the prediction of age 25, 24 years person that the salary will be 90K. You are able to make that prediction. Why? There is several reasons. Because the data set is very limited and the pattern in the data is very easy to find. The pattern in the data is very easy to find. But imagine if I have given lakhs of rows of data right now, and where you do not predict the salary of a person by age, you predict the salary of the person by age, experience, by his education, by his previous job, credit score, everything. We are predicting the salary of a person by all these parameters. So the complexity will increase, and if the complexity will be increased, guys, then you cannot tell me the pattern like this. Then you will not be able to make some prediction. And that's why our algorithm will be needed in that scenario. That's why our machine learning algorithm will play a vital role. It needs to understand that complex data. It need to understand and identify the pattern inside the complex data. And then it would be able to make some sort of a prediction, guys, right now. Okay. So if I ask you, and you guys told me the salary of a person right now, based upon the age, you have predict the salary of a person. Now, what we call X is our input data and Y is our output data. We have already talked about it right now. Okay. So if you try to see inside the data set, whatever we wanted to, what we wanted to predict, guys, can you tell me what we wanted to predict inside this? We wanted to predict salary of the person, no? Yes or no, guys? Using age, using age, we are predicting the salary of a person. So you guys can see
Yes.
age and salary both are present in my table or not? Yes or no, guys? Age and salary both is present or not? In my table only or not?
Yes, sir.
Yes. So
Yes.
whenever you are making prediction, whenever you are making prediction and your data, whatever you are making the prediction, that data is present in your data set, that data is present in your data set, it would fall under which kind of category? It would fall under supervised learning. So you can say your X and Y both are present in my data set. That means this kind of a machine learning problem that we are going to solve, we are going to call it as a supervised learning actually. Okay, where our X and Y input and output data both should be present in my data set. Both should be present in my table. Then we are going to call it as a supervised learning. Now, another example I'm taking, right? Age and salary. Age and salary. Age is 20, salary is 50K. Age is 21, salary is 60K. Age is 24, salary is 90K. Age is 22, salary is 70K. Age is 23, salary is 80K. This is my data set, guys. What I wanted to predict, if you try to see, guys, I wanted to predict whether the person is rich or poor. Whether the person is rich or poor, I wanted to predict right now. Okay, I just wanted to predict whether the person is rich and poor based upon his age, based upon his salary both. If you try to see this time, based upon age and salary both, based upon age and salary both, we wanted to make prediction whether the person is rich or whether the person is poor right now. So can you tell me, guys,
Sure.
whatever we wanted to predict, rich and poor, is it present inside the data or not? Rich and poor, is it present inside my data? We wanted to predict what? Whether the person is rich or poor right now. Tell me whether rich and poor data, is it present here anywhere? Anywhere it is present in my data set.
No.
So whatever we wanted to predict, that would be called as Y or not, guys? Whatever we wanted to predict. We have seen now. We wanted to predict here salary. So salary was Y. Here we wanted to predict rich and poor. So Y will be what? Rich and poor. And age and salary will be what? This can be your X1 column. This can be your X2 column right now. You can say overall, this is your X data. Okay. Now tell me honestly, inside this table, do we have X and Y both, or we just have X data? Tell me. Do we have X and Y both, or we are having X data only? You guys have to tell. See, guys.
Only X data.
Oh, very good. So only X data we are having right now. So here inside this table, only we are having X data and we don't have Y data. So that means this kind of data we are going to solve using unsupervised learning. Where we just have X data, we are going to solve using unsupervised. Where we are having X and Y both, that we are going to solve using supervised learning right now. Okay, got it? Now again, I'm calling it right now. X data we are calling as which kind of data, guys? Input data. This is very important. Y data we are going to call it is what? Output data. Output
Output.
data means what right now? Output data means what? Predicted data, predicted values right now. Okay, predicted values right now, or you can call it as a dependent data. But you guys can just
Dependent.
imagine input data and output data. This is X is input data and Y is output data. Now, guys, in supervised machine learning, there is a lots of algorithm is there. Lots of famous machine learning algorithm is there, and those algorithms are very, very important in terms of interview perspective, guys. First, we start with our one of the famous algorithm, that is linear regression. Then we are having logistic regression, guys. Then we are having random forest regression. Okay, random forest regression we are having, and random forest classifier we are having right now. Okay, we are having decision tree, guys. Decision tree also we are having, regressor, classifier, guys. Okay, we are having naive Bayes algorithm, we are having Cannon algorithm, we are having SVM algorithm right now, we are having SVC algorithm right now. Okay, we are having boosting algorithms right now. You can say like lots of 20-30 different algorithms we are having in supervised learning right now. Okay, only supervised I'm talking about right now. Okay, so these algorithms is very important to understand from the scratch with the whenever you are going to represent on the data, whenever you are going to use the data. And this is one of the most confusing things that comes for a data scientist or a data analyst, or like what you can say AI engineer, that which algorithm we should use on which kind of a data. And many people fail in that pass. Why they fail, guys? Because they do not understand the algorithm from the scratch. And if you don't have the understanding of algorithm from the scratch, guys, I'm honestly telling you, you're just wasting your time and just randomly checking this algorithm on this data, this algorithm on this data. You are randomly wasting your time right now. Unless you are having the complete deep understanding of the algorithm, you cannot make a better machine learning model. You cannot make a better AI model actually. Okay, it would be like that randomly chat GPT or anything would recommend something and you will not be able to do. Okay, so for that example, today only we are going to actually understand linear regression from the scratch. One algorithm at least whatever the time we are having, we'll try to understand one algorithm from the scratch, linear regression algorithm from the scratch. Okay, so let's try to understand the linear regression algorithm from the scratch, guys. One of the most interesting algorithm. Okay, linear regression. So guys, linear regression is derived from the word linear function. Linear function. Okay. So guys, tell me if you guys have did up to class 10th mathematics, that is also fine. Can you tell me what is the formula of linear function in mathematics? At least tell me quadratic function. What is the formula for quadratic function, guys? Example of quadratic function. You guys have heard about linear function, guys. Linear function, what is the formula we are having, guys? Y is equal to ax plus b. You guys have heard about it or not? In mathematics, you have
Yes.
heard about or not? Obviously, we have heard of y is equal to ax plus b. Okay. Now, what I'm doing, I'm just changing a small thing. There's nothing variable name I'm changing right now. I'm writing y is equal to mx plus c. No change at all. Okay. It's just a variable name I changed because this is the classical formula that we use. It y is equal to mx plus c. Linear function means, guys, on the graph, linear data. Linear data means a straight line. Linear means what, guys? Whenever linear words come in anywhere, na, linear means straight. Straight line right now. Simple straight line. So here, if you try to understand, when we call it as a linear function, this is the mathematical formula. Okay, y is equal to mx plus c. I'm asking x is what we have understood. X what we have understood right now. X is what right now, guys? Input data. X is what?
In
Input data. And what is Y right now, guys? What is Y? Out
output.
data. Now we don't know about M and we don't know about C. We don't know about M and we don't know about C right now. Now, if we know about M and C, if we know what is M and if we know what is C, guys, will be able to equate Y or not? If you know what is the value of M, if you know what is the value of C, we will be able to calculate for Y. Easily we will be able to calculate for Y. There is no issues at all. Okay. For now, what I'm doing, guys, we need to understand what is M and C first of all. So I told you linear function is nothing but, guys, it's just a straight line. Just simply a straight line. So this is your x-axis and this is your y-axis. And what is a straight line, guys? Simple, guys. Just made a straight line here right now. This is a straight line. Okay. And this straight line formula is what right now, guys? This straight line formula is y is equal to mx plus c. Everything will make sense. Just have a patience of 10 minutes. Everything is going to make a sense for you. So y is equal to what we got, mx plus c. And this straight line we created for that graph. Okay. Now, what is m and c? M is nothing but, guys, m is the angle. M is nothing but angle of the line. Angle means slope. What we call it is a slope, guys. So this is your m value. That is nothing but your slope. Okay. Many people may have seen this thing, na, ki like we learn about mathematics and all this thing where we are going to use this mathematics. You guys came into the AI domain actually. So everything inside it, it's part of mathematics. Everything, whether you understand about trigonometric, whether you understand about algebra, whether you understand about some basic calculation, everything is going to make sense inside AI domain actually, guys. And if you don't have understanding, definitely it would be problematic. Okay. So problematic in the sense that you have to understand that part. So what I told you, that m is nothing but m is the slope. Slope means angle of the line. And c value is what right now, guys? C value is the place where the line is cutting your y-axis. This is your y-axis. This is your y-axis. So the y-axis is getting cut at this point. So this value become our c. C is called as intercept, guys. C is called as intercept right now. M is what right now? Slope. So now we at least understood what is C, what is M. We understood about what is M and what is C. M is nothing but slope. C is nothing but, guys, intercept value right now. Okay. Now I will show you something. Just try to see. Just try to see this thing. What I did it, guys, I have taken some age value. Same thing. Age value. I'm trying to have some salary. Age is 20, 21, 22, 23. Salary is 20, 50K, 60. K I'm not writing, 50, 60, 70, 80. We have to predict what would be the salary of this person right now, 24 age person. what is the equation we are having, guys? We are having the equation y is equal to mx plus c right now. Y is equal to mx plus c. Using this equation, we are going to make the prediction. Okay. So we wanted to predict for age 24, age 24%. So we wanted to predict for age 24. So that means we can say x value will be what, guys? X value we are going to give 24 here. Okay. We don't know m value, we don't know c value. We don't know any m value, we don't know any c value. So what I'm doing, guys, what I'm simply doing, and randomly, let's randomly, no issues at all, just let's give it random. Let's randomly take m value, randomly take c value. So for now, randomly m value I have taken 2 and c value I have taken minus 10. C value I have taken minus 10. Okay. M value 2 and C value minus 10 I have taken right now. Okay. So M value we also know now and C value also we know now. Okay. So that means X value was what? 24. X value was 24. M value we know, C value we know. So can we calculate Y or not? Yes or no, guys? Can we calculate Y or not? Yes or no? Can we calculate Y or not? Yes or no, guys? Obviously.
Yes.
So for calculating Y, what we are going to do, guys, here right now? M value is 2. 2 multiplied by X value is what right now, guys? 24. And C value is what right now? Plus C value is what right now? Minus 10. What is the Y value we are going to get it, guys, right now? Y value what we are going to get? 38. Y value what we are going to get? 38. Now you guys tell me one thing. You guys tell me one thing right now. We are getting 38K salary. 38K salary of the person. 38K salary of the person. We are getting it right now. You guys tell me, is it looking correct or incorrect in your opinion? Is it looking correct or incorrect in your opinion? Hmm?
Incorrect.
Obviously, it is looking incorrect to me because ideally, based on the pattern, it should be 90K. Now try to understand this 38 value you got it. It was based upon M and C value. You have predicted based upon M and C value. So imagine a scenario where we choose perfect M and perfect C value. We will be able to get the answer or not? Definitely we will be able to get the answer. Now just check it right now. Now just check it. I'm taking a different M and C value this time. Just see. I'm taking M value this time 3 right now. I'm just taking M value 3. Hypothetically, imagine M value I have taken 3 right now. M value 3. Now C value what I'm taking, C value I'm taking around 18. C value I'm taking around 18. Now put inside the equation, guys. 3 into 24 plus 18, guys. What we are going to get it? What we are going to get it? This time what we are going to get? Calculate it, guys, quickly. What we are going to get, guys? This time we are going to get what? 90. We are going to get 90.
90.
So now this time we have predicted 90. Now tell me this time, are you getting correct result or incorrect result? This time, just tell me. 90, you got it. What do you think? Correct result. So now can you say one thing, guys? Whatever we are making prediction, it is totally depend upon this MNC value or not. If you take correct MNC value, you will be able to make prediction correct. You'll be able to make the prediction correct. If you take incorrect MNC value, you will be not able to make the correct prediction. Okay? You're understanding this point or not, guys? Yes or no?
Yes. Yes.
Now the whole idea, the whole game of linear regression is what right now, guys? This is the main crux of linear regression algorithm. If anyone is asking what actually we do to, like, what actually we do in linear regression, the main crux that we do in linear regression to find the best M value. You can say we try to find always the best M value. We don't know, but we try to find the best M value and we try to find the best C value right now. If we are able to find the best M and C value, guys, then definitely you are able to make the correct prediction. If you don't find the best M and C value, you will not be able to make the correct prediction. Okay. So the whole idea is to find the best M and C value right now. This is the main and whole idea, right? Okay. So now what I'm going to do, guys, just try to see this thing. I'm going to take this X value. I'm going to take this Y value. Okay. And I'm going to take one more data point, and there is a reason. X, Y, one I have taken, Y I have taken also one, just for simplicity, guys. Just for simplicity, X and Y both I'm taking one. X is 2, Y is 2, X is 3, Y is 3 right now. Okay. So we have already a formula that is called Y is equal to mx plus c, right? We have formula. Okay. I'm writing one more formula, guys. I'm writing one more formula. H of theta x is equal to theta 1x plus theta naught. Already, like, although the formula is little looking complex, guys, just a little looking complex, but guys, is it not the same kind of formula, only the variable name change or not? Just tell me, you guys just analyze and tell me, is it not the same formula, only the variable name is changed? Yes or no, guys? Just see the formula. Here, theta 1 is what, guys? You just tell me. Theta 1 is what? Theta 1 is what right now, guys? Theta 1 is nothing but your m value. Okay. X is what right now? X is your input data. X is normally. Theta naught is what right now, guys? Theta naught is your C value. Okay. Nothing more I am doing right now, guys. Kuch bhi nahi kar raha. There is nothing I am doing right now. I'm just writing simply one more equation for it. Why I'm writing, guys? Because there is a reason. X and Y both is present right now. I wanted to make my own prediction. I wanted to have my own prediction. So I cannot represent my prediction again with Y value variable. I can't represent because it would create a confusion for me. It would definitely create a confusion for me. So what I did it right now, we created one more new variable, h of theta x, and that's what we are going to call it as our prediction. Okay, that this will be called as our prediction right now. This s of theta x will be called as prediction right now. So here we are going to use our h of theta x, h of theta x, and nothing is changed into it, guys. Theta 1 is m, theta naught is c, nothing is changed. I'm just creating a new variable, and that new variable I'm going to call it as a h of theta x. Okay, h of theta x means your prediction value, your predicted data right now, nothing more into it. Okay. So now what I'm doing, guys, right? I'm just trying to plot this data point. Just going and plotting this data point. 1, 2, 3, x1, y1, x2, y2, x3, y3. Just plotting this data on the graph. Just plotting this data. Okay. This is your x. This is your y right now. So this would be 1. This would be 2. This would be 3. This would be 1. This would be 2. This would be 3 right now. Okay. Now this 1 comma 1, x is 1, y is 1. So this would be the point where x is 1 and y is 1. X is 1 and y is 1, guys. X is 1 and y is 1. You can see right now. Okay. So that would be the point. X is 2 and y is 2. This would be the point, guys. You can see directly. This would be the point right now. X is 3 and y is 3. This would be the point right now here. Okay. So this is the representation of your this data. So this is what 1 comma 1, this is 2 comma 2, this is 3 comma 3. This is the representation right now. Okay. So now we have to make our prediction line, guys. We have to make our y is equal to mx plus c. You can say we have to make our prediction line. Okay. I will ask you one question right now, and you guys have to tell me one thing. And you need to try to see, first of all. This is the first prediction line I'm making. This is the first prediction line I'm making. And inside this prediction line, I will tell you how to make the prediction. Okay. How to make the prediction. So for x is equal to 1, guys, try to see for x is equal to 1. If you try to see for this value, x is equal to 1, we wanted to know what we are predicting, what this line is predicting right now. We wanted to know what this line is predicting. This line is having already m and c value. We wanted to know what this line is going to predict for x is equal to 1. So this is our x-axis. This is our x-axis. You guys can see right now. On this x-axis, this is your x value y1 right now. This is your x value 1. And if you try to see right now, for x is equal to 1, what our line is predicting, not the point, that is actual point. What our line is predicting, if you try to see something, it would cut it here right now or not. So this value will come what, guys? Roughly tell me. This value will be coming what? What our line is predicting, guys? This value will be what? Where I am doing circling, what this value will be there? Y value will be what here right now, guys? Tell me. Just tell me the value. Rough value, whatever it's going to come. Just tell me, na?
4
What?
1
Nearly 4 or
4.
3.8, something like that. So suppose we got it, our predicted value, it is 3.8, something like that. Okay. For x is equal to 2, also we have to tell, you guys have to tell. For x is equal to 2 right now. So for x is equal to 2, if you try to see, our intersection is going somewhat here. So nearly it is coming here right now. Nearly it is coming here right now. So if you try to see right now on this also, we are getting nearly somewhat value called 5. Okay. Now tell me, guys, x value was 1 and we predicted 3.8. X value was 2. We predicted 5. Is it a correct prediction or incorrect prediction? You guys tell. Is it a correct prediction or incorrect prediction?
Incorrect.
Why? Because for x is equal to 1, our actual value is what? 1 only. For x is equal to 2, our actual value is what? 2 only. You can see. For
2.
x1, actual value is 1. For x2, actual value is 2. For x3, actual value is 3. But what we are doing, guys, for x1, we are predicting 3.8. For x2, we are predicting 5. That is incorrect prediction right now. That is totally incorrect prediction. Okay. Now I'm asking you one thing, one more thing here. Let's try to see. This line I'm calling as a first line right now. This line I'm calling first line. Okay. And this line I'm calling second line right now. This line I'm making second line right now. Okay. So now tell me, guys, for x is equal to 1 this time, for x is equal to 1, what we are predicting? What we are predicting this time for x is equal to 1? Tell me. This line, second line. For x is equal to 1, what we are predicting, guys, this time? Our line, what it is predicting? Where the intersection
1.
is there? 1. Very good, very good. And for x is equal to 2, if you try to see x is equal to 2, it was there. But we are making predictions somewhat here. So for x is equal to 2, what we are predicting, guys, right now? Something, some value?
2.2, 2.3 something.
2.3 something right now. Okay. Now I'm asking you one thing, and that question is very, very important for solving this. This was our first line, and this was our second line right now. This was the result we got it. Which line is making more better prediction? The first line is making more better prediction, or the second line is making more better prediction, in your opinion? Better
Second
prediction.
line making more.
Exactly 100%. Second line is making more
Yeah,
better prediction.
more better.
Okay. So what we can see, this is your actual data points. If you try to see, guys, this, it's very important to understand. This is your actual data point. This is your actual data point. This is your actual data point. So which line will make more better prediction? The line which is closer to the data points, or the line which is far from the data point? These are your data points, guys. Huh? Which line will make more better prediction? The line which
Closer
is
to data points.
or far from the data points?
Closer to data points.
Very good. Closer to the data points right now. Okay. Now, what I'm asking you, just try to see. See this thing. This is few data points we are having. Suppose this is few data points we are having. Few data points we are having. This is the first line that I have drawn. This is the first line we are drawing. This is the second line I have drawn. Okay. And this is the third line I'm drawing right now. Okay. Now tell me guys, which line is making more better prediction? First, second, third. Which line is making more better prediction in your opinion? First, second,
Second
third.
line.
Second line is making more better prediction because it
More
is
better
closer to
prediction.
the data point. And this line we are going to call it is what right now, guys? This line we are going to famously known as best fit line. If in an interview, very important interview question, what is best fit line in linear regression? Best fit line is that line in linear regression where our line crosses the data point, you can say, or where our line is more closer to the data points right now. That line is called as a best fit line. Okay. Now, guys, if I ask you here, let's come back into the previous step. So here, our actual value was 1, but we predicted 3.8. Actual value was 1, and we predicted 3.8. Okay. So if our actual value was 1 and we predicted 3.8, how much error we are having right now? How much like differences we are having? Differences, error means differences here. How much difference we are having right now? Nearly tell me.
2.8.
2.8. Very good. Now, for our actual value 1, we predicted 1 from the second line. For our actual value 1, we predicted 1. So what is the differences this time we are having right now?
0.
0 right now. That is very good. So now this differences, I'm giving a terminology, I'm giving a new terminology. This difference is nothing but we are going to call it as error. What we are going to call it is error. Okay. This differences we are going to call it as a error right now.
Error.
Okay. Error. Very important. What is error? Okay, we will understand, but this differences we are calling it as a nothing but error right now. Now tell me guys, for making better prediction, error should be high or low? Simple. For making
Low.
better prediction, error should be
Low.
very good. So the whole idea of this complete linear regression is what right now you can say we have to increase the error or we have to decrease the error right now. Tell me.
Decrease the.
Decrease the error. Very, very good. So we have to try to decrease the error. And if we decrease the error, then automatically we are getting the best result or not? If we decrease the
Yes.
error. Yes, very good. So
Yes.
now, if we wanted to calculate the error, just tell me, if I wanted to calculate the error for this data point, how we can calculate the error? So prediction value, what we have given, prediction value, what we are denoting right now, h of theta x right now. This is, we call it as a prediction value right now. What we are calling it as a prediction value. Okay. So this we are denoting with h of theta x. And if you guys want, I can give it some other denotation. Suppose, let me give it some other denotation. Okay. Because you guys are getting confused in h of theta x. So I will not use any h of theta x for now. No use of h of theta x. This I'm going to call as y actual, and this I'm going to call as y prediction right now. Y actual and y prediction. So if I wanted to calculate the error, that means differences, you can say, we can calculate by y prediction minus y actual data or not. Yes or no, guys? If I wanted to calculate the error,
Yes.
this is how
Yes.
we can calculate the error right now. Okay. Now, should we calculate the data for one data point or should we calculate the error for every data point? What do you guys think? We should calculate for every data point, no? Yes or no, guys?
Yes. Every
So
data
for
point.
the first data point you calculated there, second data point is also there, third data point is also there. For every data point, we have to calculate the error actually. So for the error calculation in linear regression, we got a formula, guys. I'm directly jumping on the formula. Okay. We got the formula. What the formula we got it? Y prediction. Y prediction. Y prediction. That is our predicted data minus Y actual data. Y prediction minus Y actual data. Okay. And that we have to do for one data point for all the data points. Y prediction minus Y
All
actual
the data points.
all the data points. So suppose if we wanted to do all the data points, how we denote in mathematics, let me tell you, we denote in mathematics by some value called I. Okay. I means what here I can be, guys. I can be from for first data point, I can be for the second data point, I can be for the third data points. So for all the data points, we will calculate it right now. Okay, for all the data point. For example, suppose for the first data point, for I is equal to 1, for the first data point, we got the error -10. Okay, and for the second data point, I is equal to 2, we got the error +10, guys, right now. +10. Okay, for the first data point, we got the error -10, and for the second data point, we got the error +10 right now. +10. Okay, now try to understand. Suppose we are having 1,000 data points, how many errors we are going to get it? If we are having 1,000 data points, how many errors we are going to get it? Tell me, guys. If we are having 2 data points, we are getting 2 errors. So if we are having 1,000 data points, how many errors we are going to get it right? Tell me, guys. If you are having 1,000 data points, how many errors we are going to get? 1,000, guys. Suppose here, if I
Thousands.
here if I ask you how many errors I'm going to get it from here, how many errors we are going to get it right now here in this? How many data points we are having, guys? Tell me. First data point, second data point,
3.
third. So 3 errors we are going to do. Now the problem is what, guys? You are having 1,000 error, 1,000 values. We wanted to get one values for this. For 1,000 value, we wanted to just get one what you can say, one average error. Okay, one average error we wanted to get. We don't wanted to get 1,000 different error. We just wanted to consolidate into one average error. Okay, so what we are going to do, we are going to find out the average of these 1,000 values, average of these 3 values, average of these 2 errors that we are getting right now. So tell me how to calculate the average here right now. Average here right now. How to calculate the average here? What will be the average of -10 and +10, guys? How we will calculate? -10 +10 divided by which value, guys, right now? Divide by
2.
2 right now. What is the answer I'm going to get it here right now? -10 +10, what would it become, guys? 0, na? Yes or no, guys? -10 +10. So error, what we are going to get it? Average error, what we are going to get it right now?
0, sir.
0. We are going to get 0 right now. Now, honestly, tell me, we got -10 error. We got +10 error. Average error is coming 0. So that means overall, you will understand there is no error. And there is no error. What is reflecting, guys? Best, like good result or bad result if there is no error? Honestly, tell me, if the error is already very low, near to 0, that means already it is very good result or not? I told you one thing, na? Here, if you
Yes.
to see here in this question, when your error comes 0, you told that okay, this is better prediction. This line is better prediction. When the error was coming 2.8, you were saying okay, it was not better prediction right now. So that means when error is very low, near to 0, error is very low. There, error is near to 0. That means it is actually very good result. It is the best result we are getting from this. But you know, guys, actually it is not. It is not. -10 is some error. +10 is some error. The only thing is coming when you do the summation of -10 and +10, it is impacting your average values. So we cannot use -10 +10 directly. Okay. What we have to do is we have to use mod function. We have to use mod function. Why we have to use? Otherwise, if we combine, if -5 +5 it is coming, overall error will be coming 0. You will understand there is no error. But there are several errors. There are some error of -5 and there is some error of +5. Okay, you are summing it up and you are making error 0. That is not the case. Okay, so what we do, every negative values we convert into positive values. Simply
Mod.
every negative values we convert into positive value, and every negative value we can convert using positive value using which function? Modulus function right now.
Mod.
What we will do right now, we will use mod function. Okay, we
Mod
can use
function.
mod function right now. Okay, now we have to do for one data point and we have to do the summation. And summation, if you guys remember, if you need to do summation in mathematics, guys, we use summation function, guys. We use summation function for first data point to the last data point, from I is equal to 1 to I is equal to 1, for first data point to the last data point. N is like total number of data points. And for calculating the average, we have to divide by which value, guys? We have to divide by what right now for calculating the average? We have to divide by the n. N is what nothing but number of data points. Number of
Data
data points.
points.
Here was number of data points 2. Here it would become 2 right now. So if the number of data points is 1000, so n value become 1000 right now. And this is
1000.
how you calculate the error. This is how you calculate the error actually. Okay. And if you are able to calculate the error, suppose you are able to calculate 1000 error, like you got the error minus 100, not minus 100, suppose minus, you will not get it because modulus already you use it. You are getting 100 as a error. Average error what you are getting right now, you are getting as 100, you are getting 50, you are getting 60, you are getting 10, you are getting 20, you are getting suppose 5, you are getting 90. Okay, so which error value will be the best for my prediction? Out of this, which error value will be best for my prediction, guys? Tell me, which error value will be the best for my prediction?
5.
5 will be my error value. That is very correct answer right now. So 5 error value will be best for my prediction. So what I need to do at the last, I just need to select the least error. And if I am able to select the least error, I know I am able to make the correct prediction right now. So overall, in summary, if we wanted to understand, okay, if I wanted to understand overall in summary, what is linear regression, what we are doing. So first of all, in linear regression, we are using a formula. What the formula we are using right now? We are using a formula called y is equal to mx plus c right now.
MX
Okay.
plus C.
And inside mx plus c, m is what right now? Slope. And c is what? Intercept value right now. If you wanted to
Y
make the
intercept.
prediction, yeah, if you wanted to make the prediction, what we need to find out? We need to find out best m value and we need to find out best c value. We need to find best m value and we need to find best c value. Okay, and for finding the best m and best c value, what actually we need to do, if you try to understand, guys, we have to find the best fit line. We have to find what? Best fit line. So best fit line will be having higher average error or lower average error. The best fit line, guys, what do you guys think? The best fit line will have high error or low error right now?
Low error.
Very good. The best fit line will be having the lower error. So whole idea is right now what? You have to find the least error. You have to find the least error. If you're able to find the least error, that means you are able to find the best fit line. And once you find the best fit line, that means you are able to find the best M and best C value. That means, guys, if you try to see, guys, we got the best fit line here for this data. Okay. So I need to know what? I need to know what simply? I simply now need to know the slope, that is m value, and I need to know the intercept, that is c value. So I got my m value, I got my c value. I am able to make the prediction using y is equal to mx plus c or not? Yes or no, guys? Tell me.
Yes.
That's I'm able to know it right now. This is the main crux of linear regression. And what I did it here, guys, I have explained you only 10 to 15% of the linear regression. Only 10 to 15% of the linear regression from the scratch. Actually, the algorithm is such like that where you will see the differential equation integrations and everything. I don't wanted to go into that direction because for understanding this thing, you have to be in zone of what you can say, you have to be zone in mathematics, you have to be in the zone of learning this machine learning in a way, in a proper way. Then I can show you exact calculation like that h of theta x calculation, theta 1 calculation, theta naught calculation, gradient descendant, everything I can explain. Okay, this is just an like a overview of the linear regression, how this is right now. Okay, and how the math algorithm actually make the prediction actually. Okay, so let's do a small prediction with this linear regression. Let's try to make some small prediction inside the practical and let's see how it predict the result only, right? So let's try to see the prediction, guys. If you have any question, you guys can let me know. Anyone having any question, guys, right now? Anyone having any question right now, guys? Okay, so let's try to do some sort of a prediction right now using linear regression. Yes. File, open session. This one. Let me do in collab so that I can share you the file also. We will use this. Let's try to use this movies data right now. I'll use the collab guys right now. Let me import pandas as PD. Import pandas as PD. df is equal to pd.read underscore csv. I will read the data. Okay. Simply, I will read the data. The data set is already cleaned and some analysis already we have did it. Okay. So I will just go and start the prediction right now. Okay. So how we will do the prediction, you guys will see, right? Okay. So what we are doing guys right now, this is the movies data. Okay, this is the movies data, and we are having collection of the movies. This is in million, $2.26 million collection, $2.10 million collection, $2.98 million, $2.893.080 million collection. This is the collection of the movies over the time right now. Okay, so we are predicting the collection of a movie. We are predicting the collection of a movies with a lot of different column we are having, but I'm going to select only one column. We will predict the collection of the movie with the trailer view. Like movies releases their trailers, and this is the views of the trailers right now. So we are trying to simply make the prediction using trailer views. So we are saying using the trailer views of a movie, I'm going to make some sort of a prediction right now. So I'm going to select a column. So X, I'm selecting what guys? You can say df of trailer views, trailer underscore views. Our X data would be X of data will be trailer underscore views right now. This would be our X data. Y data, what I'm selecting, we wanted to make the prediction of the collection of a movie. So Y data, we are taking collection. So what we have taken, guys, this is our X data. X means using this trailer views, we are going to make some sort of a prediction. And this is your actual data. Okay. So this is your actual data. So X and Y both we are having. Obviously, we are going to use which kind of algorithm, guys? We are going to use linear regression algorithm for it right now. Okay. So using X and Y, we are going to make the prediction. X is trailer views and Y is collection of a movie. And we just understood the linear regression algorithm. So let's try to do using linear regression algorithm right now. So what we will do, we will simply go and try to implement linear regression. So this linear regression is actually present inside a module called sklearn, guys. So what we'll write from sklearn dot linear. What we'll write sklearn dot linear underscore model. We will import what, guys? We will import linear regression algorithm. Linear regression algorithm. Okay, simply what we did it, we imported linear regression algorithm from the linear model right now. What we are going to do? Then we are going to create a linear regression model object. We have to create linear regression model object. So linear regression model object we have created, and we have stored inside the LR variable. Okay. So now we will run it. So linear regression model object we have created. Now what we will do? We will fit our X and Y both data here. We will fit our data now. So lr.fit we are going to use, and we are going to fit our X and Y both data. Now what it is going to do, guys? This is pre-built linear regression algorithm, and all the algorithm will be you guys will be provided using sklearn modules and packages right now. So you can import any algorithm, linear regression, logistic, like ensemble, any algorithm you can import from it. You create the object of that algorithm, and then you can simply fit the data. And once you fit the data, you run this query, run this code, automatically, guys, what it will do, this internally in the back end, all the mathematical computation, training of that model, everything would be done, and your data would be fitted on the linear regression model. So let me just run it. My data is now fitted on my linear regression model. It's done. It's fitted. So if the data is fitted, our training has been done right now. Least error has been calculated. Everything is done. Now you are ready for making any prediction. Now you are actually ready for making any kind of prediction. Let me show you right now. Okay. So if I wanted to make some prediction, just try to see lr dot predict, lr dot predict. And inside this, guys, what I need to do, simply I need to give some trailer view. Suppose I need to know, suppose my trailer views is 5,64,960. This is my trailer views. I'm saying if my trailer views is 5,64,968 views, what my movie will be earning, what my movie will earn, what is the collection my movie is going to do. So I'm doing the prediction for this trailer views. 5,64,968 views. If my trailer is getting, my movie will collect around $2.9 million. My movie will earn $2.9 million. So suppose I'm saying if my trailer views is nearly not 5 lakh, it is nearly 9 lakh 64,000. Then what is the collection my movie is going to make? It is saying your movie is going to make nearly $5.46 million collection right now. And this is how much easier, this is how much easy to make some sort of a prediction using linear regression algorithm right now. Okay, just simple like this. Now I told you one thing, if you remember, there is some slope value, there is some intercept value. That slope value and that intercept value is actually making the prediction. That slope and intercept. And let me showcase you actually that slope and intercept. So slope value comes inside in linear regression lr dot, I guess if I'm able to remember, this comes in lr dot coefficient variable. So coefficient, lr dot coefficient, it is nothing but it is actually your slope value, guys. It is nothing but it is your slope value. Okay. So let me just run it one more time. I wanted to store in a variable so that I can show you how does it actually works. It is running still. Just running, guys. Let it run. Hmm. So now I will store, this is coefficient. This coefficient is nothing but, guys, it is your slope value. So I will store into m variable. Slope is what? M variable. And now C value, that is intercept, we are going to get it from LR dot, I guess if I'm not wrong, intercept or some variable. Yes, intercept. LR dot intercept. Let me showcase you what is the intercept value it is coming. It is coming minus 0 point something. So this is our C value. Okay. Now, guys, tell me the formula. Quickly tell me the formula. What is the formula for making the prediction? What is the formula that we have learned today for linear regression? Quickly tell me, guys. What is the
Y
formula
is
for
equal to mx plus c.
mx plus c? So now m value is what right now? M inside m variable we are getting. And x value is what? What is the user input? 9,64,968. So we'll copy and put it here right now. M x, m into x. And plus c is what right now? Plus our this c value that we got it. Mx plus c. And we are getting exactly the same value or not, guys? We're exactly getting the same value now, 5.46. And here also we are getting the same 5.46 value right now, because we use the formula, we understood the formula right now, and now we are able to directly use the formula. M value we can get it, C value we can get it right now, and we can simply write in the mathematical formula mx plus c right now, and we are able to make some sort of a predictions out of it, right? We are able to make some good prediction out of it actually. Okay, and this is how to use linear regression algorithm. Okay, similarly you can use any of the algorithm, any of the algorithm that you wanted to use: logistic regression, random forest classifier, decision tree regression, whatever the algorithm you guys wanted to use, you can use it very easily right now. Okay, understood this part right now, how to use it? So suppose guys, you guys have been assigned project. Tomorrow will be the end-to-end project work. Project work inside it, where you guys will be taking, where we will be taking a data. You will get the data. Inside the data, you will load it. You will clean the data. You will do some sort of a data analysis basic, and then you will try to make the some sort of machine learning model out of it. Right now, that would be showcased tomorrow, completely end-to-end executions of it right now. Okay. And other than that, if you try to see here right now, I'll share you the file actually. Okay, I'll share you the file. Just a second, so that you guys can use it for your predictions later on. And with the link, copy the link. Okay. Hmm. Just a second. Yes. Yeah, I've shared the file. You guys can now use that same file. You can click on that file, copy the link of the file. You can go in Collab and you can actually do the practical from yourself right now. You can actually make some sort of prediction. My like our fundamental is not right now currently how much good you are making prediction, how much bad you are making prediction. This fundamental is right now what you should understand, and you should be able to make some sort of a prediction using it right now. You will be able to make some sort of prediction using it right now. Okay. Anyone having any kind of a question, any kind of a doubt, guys? Any kind of a doubt you guys are having regarding this thing? Now, guys, what actually we do into the production in real time production? We simply save this model, whatever the model you have created, linear regression model and all those things. We save this model. Let me showcase you. There are some GitHub project already deployed right now. Suppose this is some, mm, for example, let's take this YouTube analysis is one having or not. See, so inside this, if you try to see, this is a YouTube analysis project. We had it in past days right now. Inside this, if you try to see, guys, we have created our machine learning model. I'll show you the same thing right now. So here in app.py or data cleaning, it has been done right now. Let me see. So if you try to see, we loaded the data. After loaded the data, we cleaned the data, did a lot of work onto the data actually. Okay. And I guess it was until the cleaning. Any other file we are having right now? US video, DS session, test.ipy. What is that? That is for database creations and all right now. I don't think so. Any other file we are having. This model.pickle pkl file that you are seeing right now, this is your actual model. Model.pickle file is your actual model. That means once you created your algorithm, linear regression, logistic regression, and all, you can save that model in pickle file and you can directly use that model in your production. Maybe I am pretty much sure in some other project, the, it should be present how we convert it also. Let me showcase you. I guess in OLX it was present. Let me just check it. In OLS data cleaning, model.pickle, OLX analysis.ipynb. Let's try to see in this data. So this is cleaning works, encoding, all this work has been done. And now if you try to see here, here we created linear regression model. If you try to see lr.linear regression model, we fitted the data, we check the accuracy score. These are the things that we do it, guys. We check the accuracy score right now, and then we make some sort of a prediction using the model. What we did it importantly, if you try to see the last line of the code, guys, we imported the pickle file, and what we are trying to do, this linear regression model, this line, just see your linear regression model, we are dropping into model.pickle. This linear regression model, we are dropping into model.pickle right now. And once we drop that linear regression model into model.pickle, guys, now it is ready for making any kind of prediction. This now model.pickle file will predict the data for you. It's live predict the data for you. For example, I guess I'm having few like deployed project onto the render actually. So let me just go on to this one's dashboard. Yeah. So I guess let me just check it. I don't remember at all, guys, which project is running still right now, because it's been long days, like 4 5 years ago these projects was done. So let me just showcase you once. This is R1 and this is some sort of I guess let's see loan approval one also. Let's see what is that. We don't remember at all. So once it is there done, it would be able to use onto what you can say onto production. You can use in your main web applications or in your application these model. You can use it right now. Let it load, guys, because it's take little time to load the complete web app. This was a very basic project, basic stuff was done, but it would be helpful for you to understand it right now. Okay, so let it just load, guys. Meanwhile. Hmm. Loan approval has been opened. Let me just open it right now. So now it is taking some sort of a data for me. I like these are just nothing but these are input data it is taking right now. I'm just going to give it. I'm hoping that it is very like I can say 4 5 years old project actually. So I'm hoping that it's still running properly. So suppose let me give it John Cena, the name of the person. Gender of the person is male. Married it is yes. Suppose dependents, there are 3 people dependents or 2 people dependent. Education, the person is graduate. Person is self-employed, yes. Applicant income, I'm giving the person is earning around uh, like suppose $1,500 per month. Okay. Co-applicant income, the co-applicant income is $500 per month. Okay. Loan amount he want nearly $700 for the loan. And loan amount term, he wanted to give loan amount into suppose 64 months he wanted to give for the loan amount term. Okay, or let's just use 240 months for now for the same loan. Okay, 240 months. Yes, he is having credit history and property area is urban right now. So now we are taking this user will give this loan eligibility form. So user is giving this data. When we click on submit button, this data will be went into the backend. And when the data will come in the backend right now, the data will be sent where, guys? The data would be sent in our model.pickle file. The data would be sent in our model.pickle file, where our model is already trained, and now this model will be able to make some sort of prediction right now. I'm hoping that it's still running. Let me just try to submit it. I'm clicking on submit and waiting for that. Okay, so the model should give me some sort of a response whether I'm eligible, yes or no, or whether loan approved or not for me. Okay, so it's running. So it is saying for my kind of information whatever I have given, my loan will be approved right now. So this system to integrate in web applications or mobile applications or anywhere right now, you have to save your model in a pickle file or any other kind of file, and then you can use it into your production. Okay, this was end-to-end use cases of your like data, how you are going to clean it, how you are going to like analyze it, how you are going to create the machine learning model, how you can save the machine learning model right now, and how you can integrate in your web application. Okay, so obviously, guys, this timeline whatever it has been given to you guys to understand 5 days, nearly 1.5 hours every day right now. So in that timeline you can't do everything into it right now. You had to understand the complete process. That was my main agenda, to make you guys understand that you understand at least the process, what it is happening right now, what the people are using it right now, how they are trying to, how are they are able to create this machine learning model, how this project works. So that understanding, at least I guess you guys have got little bit, not a complete understanding because it's take time right now. So you guys can try to understand, and the same thing you can now try to apply onto your project also. Okay, the project that has you guys have chosen right now, the project that we have given, like whether project that we have given to you right now. Okay, tomorrow We will take one of the data set. We will personally take also the maybe weather data. Okay. And inside that, we will be able to show you the end-to-end use cases onto it right now. Your data cleaning process, your EDA process, your data analysis, how to create machine learning model, and how to save that machine learning model so that you can use anywhere wherever you want it to do, guys. Okay. Got it? So let it be like that for today only right now, because if I start the project work today, it would take more time, and I have to do and go for some session in other right now. So you guys can submit your attendance, and we will be connecting for the project work tomorrow, guys. Okay, everyone, please mark your attendance. And meanwhile, if anyone is having any kind of a doubt, doubt, you can let me know. Okay, yeah. So scan the QR code, guys, and try to fill your attendance right now. Let me just. Meanwhile, anyone is having any doubt, you guys can let me know. Everyone mark the attendance. That's all for today, guys. We will meet tomorrow, and we will try to understand about the project that I told you right now. We will try to apply that end to end on the same project. And then you guys have to submit your project report. And after you submit your project report, means your complete project you can send. And then we will try to decide the top performer based upon that. And that top performer stipend, I guess, I got from the team that it would be processed within 1 week once the top performance is announced, guys. Okay. So please prepare this thing accordingly, work accordingly, and try to make it happen. Okay. So let me just share you the attendance also in the group link so that you can do it. Okay. That's all for today, guys. Bye. Have a good day. Thank you.
Thank you, sir.
Thank you, guys.